Today we will discuss matrix, that is singular, plural is matrices. Now when we are discussing a matrix, there will be some rows and some columns. If I say matrix like this 2, 3, 5, 7, then we are having one row and 4 columns, and we write this way, there's a bracket. That means this is a matrix where one row we are finding and 4 columns are there. We also call this as a row matrix, because this is only one row with 4 columns, 1, 2, 3, 4, the vertical lines. And now if I write this as like this, 5, 1, 2, like this, then we are having one column but 3 rows. That means it is a column matrix. So a matrix may be column matrix or a row matrix. Now it is a column matrix because only one column but 3 rows. When we write a matrix, we always consider the size of the matrix as termed as order of matrix. So if I write a matrix like this, 3 minus 1, 5, 2, 0, 1, 3, 4, 5, 1, 1, 2, then we are finding 4 rows and 3 columns. We don't write and, we don't say and, we write into. That into is not into, this is by 4 rows, 3 columns. In short, we say 4 into 3 matrix. That means this matrix size is 4 rows, 3 columns. Together we are having 12 elements in the matrix, inside the bracket. And the matrix, we can say the order, size, this is the order of matrix. Order of matrix means the size of matrix. The size of matrix will be the rows and the columns will be counted. Now we have various kinds of matrix, like a square matrix will be this is square matrix. Why it is a square? Because this is 3 rows, 3 columns. It's square. It's a square matrix. It's a case of examples of square. Square matrix means the number of rows and number of column size will be same. Now what we have, if the square matrix is such a matrix, it's a square matrix. It can be another square matrix like 2, 5, 3, 7. It is a square matrix because there are 2 rows and 2 columns. Now in both these cases we can have one situation. If I have 2 here, 3 here and 1 here and whatever it is, 5, then one thing we are finding, this upper triangular portion and lower triangular portion, these 2 portions are same. Then this idea, here also you can have like this portion and that portion is same. So in case of a square matrix, if you find this one, then it is a special kind of matrix. Why? Because one thoughts we are having, this upper triangle and lower triangles. This is one important thought, that is called transpose of matrix. Transpose of a matrix is to change the rows and columns. Interchange rows and columns. Interchange rows and columns. That means if we change the rows to columns or columns to rows, then what we find is called the transpose matrix. And a matrix is like this: A, B, C, D, L, M, P, Q, P. That means 2 rows, 4 columns. So the size of the matrix we can define as 2 rows, 4 columns. Now if I take the transpose, this is called transpose. A transpose to the power t is also denoted by A dash. This transpose will be, this ABCD we will write in the vertical side. This row is now shown in the column and LMNP in the column. So now the size is not 2 into 4, 2 rows, 4 columns. It will be 4 rows, 2 columns. So transpose matrix is like this. Just before I was discussing the triangular part, the upper part and lower part, the square matrix. So if a matrix is such that A transpose is equal to A, that is only possible for a square matrix, then it is called symmetric matrix. So symmetric matrix is a matrix when the transpose of the matrix will not be changed. Like we can have an example: A, B, C, B, A, B, E, F, then C, F, G. This matrix, if I transpose this matrix, then we will find no change. Same. We will not find any change in the matrix because the situation is such diagonally. If I transpose it, if I change the order and if I change the rows and columns, no change. So this is a symmetric matrix. But if I find A transpose is equal to minus A, then it is called skew symmetric. So what is skew symmetric? If the transpose matrix, if I transpose it, it will be a negative one, like this. Diagonally we should have negative 0. Diagonally we should have this. This is the main principal direction, principal diagonal. That part is 0. Then we are finding like this. We are finding this one. So if I transpose, what we are finding, that the lower and upper part will be interchanged. Means A0 AC minus A0 minus D and minus C D0. So what has happened? This value and this value, if I compare, minus A is A is minus A. So it is nothing but A transpose is equal to minus A. So it is a case of skew symmetric matrix. Now in matrix we have a very important idea that if I multiply a matrix with a number, then the inside part of the matrix, inside values of the matrix will be get multiplied by the number. That means if I say A is a matrix 2, 5, 1, 3 minus 2, 5, then 2A, if I take 2A, if I take 2A, then what will happen? All the numbers inside the matrix, all the values 2, 5, 1, 3 minus 2, 5, everything will be multiplied by 2. That means it will become 4, 2 2s are 4, 5 2s are 10, 2 1s are 2, 3 2s are 6, 2 2s are minus 5 and 5 2s are 10. So it will become this one. So A is a matrix. If I take 2A, then it will be twice the numbers inside. Now we can have some concept, like an example. The example is A is given as A and B are given, two matrices are given. A matrix is like 1, 2, 3, 4, and B matrix is 3 minus 1 minus 2, 4 minus 2, 5. And they're asking you to find out 2A plus 3B and A minus B. Now in order to add or subtract, one very important point, that two matrices must be of same order. It has 2 rows 2 columns, and that B has 2 rows 2 columns, so we can add. And when we subtract, the same idea will be there, which should be there, that is A and B must have the same order. Yes, here A and B are of same order, 2 cross 2, 2 rows 2 columns. So what is 2A here? 2A is 2, 4, 6, 8. And what about 3B? 3B is 3 3s are 9. All numbers inside will be getting multiplied. Minus 3, minus 6, 15. Now all we need to add these two. These two are added. So the result 2A plus 3B will be 2 plus 9. The idea will be, what is the concept of addition of matrices? 2 will be added to 9. That is 2 will be added to 9, 11. 4 will be added to minus 3, that means 1. 6 will be added to minus 6, 0. 8 is added to 15, that is 23. So your answer is 11, 1, 0, 23. This is first part. That is 2A plus 3B part. Now A minus B. A minus is very simple. A minus B will be 1 will be subtracted by 3. 1 is subtracted by 3. 2 will be subtracted by minus 1, getting plus 1. 3 is subtracted by 2, that will be 3 plus 2. 4 is subtracted by 5. So the result is minus 1, 3, 5, minus 1. This is the final answer. So this is called, this is the addition, subtraction of matrices. Another very important point in matrix is null matrix. It is a zero matrix. When we say null matrix means zero matrix. That means all figures inside the matrix is 0. And unit matrix is another matrix which is very important, when all numbers diagonally is 1. That means the diagonal, principal diagonal, this diagonal will be 1. This is called unit or identity. or identity is called I matrix. I. Identity means I. As I means all numbers are identical one. Now the point is, it can be a smaller one in identity matrix or unit matrix 1 0 0 1. This is called sometimes I3 because 3 numbers are there. This is called I2 also, or simply I. Now one point that null matrix, we can have an example like A is x plus y, and then we have 3, then it is minus 3, and this is x minus y, and B is like 4, 3 minus 3, and this is 2. They are saying that find xy. There's a question if A minus B is a null matrix. It's a very simple problem. All we need to see that A minus B will be 0. That means A minus B, if I take, it should be 0. The concept of the idea of the problem will be that A minus B is what? A minus B is what? A minus B is x plus y minus 4. Then it is 3 minus 3 is 0, minus 3 minus 3, 3 minus 3, 3 minus 3, 0, x plus y minus 4. Then minus 3 minus 3, minus 3 minus 3 is 0, and x minus y minus 2. This is the idea. But this is a null matrix, so that means this should be all zeros. What is null matrix? Zero matrix. That means all figures inside the matrix should be 0. We are finding 2 zeros are there. The diagonal, this diagonal, not the principal diagonal, but the other diagonal is 0. So no problem. But other 2 numbers should be 0. That means we should have x plus y minus 4 is 0 and x minus y minus 2 is 0. So we can solve. That means if I add 2x is minus plus 6 and x is 3, and when x is 3, y should be 1. So we can have the answer as x is 3, y is 1. Then we get A minus B is null matrix. This is that one type of problem. And another type of problem we can have here is, or we can take the next topic in matrix, that is how to multiply. Multiplication of matrix. How to multiply matrix. Multiplication of matrices. Multiplication of matrix. This matrix can be multiplied with row column. Row column multiplication. Actually, it is not row column multiplication. The association will be row and column. Then we add. Like this. If I take A, B, C and element, this is a matrix here. This is showing the matrix numbers. Row is A, B, C, and then next row is element. Multiplied with another matrix P, Q, R this side, X, Y, Z. There is a very important rule to follow. The row is first row and the second row, and this is first column and second column. We will combine the row and column. This first row will be combined with first column. That means we will be writing first row combined with first column. First row combined with first column. That means ABC will be multiplied with respectively PQR. ABC multiplied with PQR. That means A into P plus B into Q plus C into R. This is the first combination. Then next one will be ABC multiplied with XYZ. A into X plus B into Y plus C into Z. That means we are multiplying A into X, A, B, C, X, Y, Z. B into Y, C into Z. Now the next row, that is element. Now instead of ABC, we will take the second row for the second row calculation of the product. Element will be multiplied with PQR, that is L into P. Instead of A, I am writing L. Instead of B, we are writing M. And instead of C, I am writing N. Why? Because now element is multiplied with the second column, first column, second row, first column, first row, first column. This is the combination. Then first row, second column. This is the combination. The second row, first column, and then second row, second column. LX, MY, NZ. So this is the idea of how to multiply matrix. So this is a rule to remember that row and column to be associated. So we can have an example, like if I have matrix A and matrix B given as A is like this, a short example. A is like 1 minus 2, 2, 1. 1 minus 2, 2, 1, and B is another matrix, that is 3, 1, 3, 1, minus 2 and minus 2 and minus 1. Minus 2 and minus 1. All we want to see what will be A into B and what will be B into A. First is A into B. A into B will be 1 minus 2, 2, 1 into 3, 1 minus 2 minus 1. Now if I look, first row will be multiplied with first column. That means 1 is multiplied with 3 and minus 2 is multiplied with minus 2. This is the first combination. First row, first column. First row, first column. Then the first row, second column. 1 is multiplied with 1. Then minus 2 is multiplied with minus 1. This is first row, second column. Done. Then 2, second row, first column. Second row, first column. Then plus 1 into minus 2. The second one, 2 into 1. Second row, second column. So row, column. Row, column. So what is happening? The result is coming to be ultimately this is 7. Why? 3 plus 4. 3 and this is minus minus plus. This is 1 plus 2. That is 3. So 7, 3. And this is 6 minus 2. 4. 6 minus 2. This is 2 minus 1 is 1. So A into B is 7, 3, 4, 1. Now let us take the other way. What will be the result for B into A? This is A into B. B into A will be this one. B into A. B first, we'll write B first, then A. We'll show that it will be not the same answer. The answer will differ. The answer will differ means first row, first column. 3, 1, first row, first column. 3 into 1 plus 1 into 2. First row, second column. 3 into minus 2 plus 1 into 1. Then second row, first column, second row, first column, minus 2 plus 1, minus 1 plus 2. So the idea is first row, first column, then first row, second column, first row, first column, first row, second column, then second row, first column, second row, second column, second row, second column is this. So what is the final answer? The final answer is 3 plus 2, that is 5. 3 plus 2 is 5. 3 plus 2 is 5. Minus 3 into 2, minus 6 plus 1. Minus 6 plus 1 is minus 5. Minus 6 plus 1. Minus 2 minus 2. Minus 2 minus 2 is minus 4. And the last one is 4 minus 1, that is 3. One is noticeable point, that is A into B is not B into A. Very important to note that in matrix A into B, in general we say B into A must be equal, but in matrix they are not generally equal. Sometimes it may be equal, but very exceptional case. That is the idea of matrix multiplication. In matrix multiplication, what we find that A is a matrix like 1, 2, 3, 4. And a question I am asking that find A square minus 5A. What will be the result? How to solve? A square minus 5A. Then what is A square? It is not A square. It is not A square is not correct. A square is actually A into A. So what you need? 1, 2, 3, 4. This matrix should be multiplied with 1, 2, 3, 4 again. And what is the result? 1, 2, 1, 3. The first row, first column. I am writing directly 1 into 1, that is 1. Plus 2 into 3 is 6. Then 1 into 2. 1 into 2 and then 2 into 4. That is 2 plus 8. Then 3 into 1, 4 into 3. This 3, 4 is multiplied with 1, 3. 3 plus 12. And then this one is multiplied with this. That is 6 plus 16. So the result is 7, 10, 15, 22. This is A square. This is not A square. If you think that A square is A square, 1 square, 2 square, 3 square, 4 square, wrong. A square is A into A. Now all you need is 5A. Then what is 5A? 5A is all the numbers inside A will be multiplied with 5. 5, 10, 15, 20. All numbers are multiplied by 5 times. Now what is a square minus 5a? Now a square minus 5a will be, a square is this and 5a is this. So what you will find that a square 7, 5a is 5. That means the numbers at the same place will be subtracted. 10 minus 10, then 15 minus 15, and 22 minus 20. So all you are finding, the final answer is 2 0. Very important to note. 0 2. So final answer is 2002. And if you watch these figures, if I take 2 outside the matrix common, then what you need will find 1001. This is identity matrix. So the result can be also said instead of 2002 as 2i. This 2i is a matrix when instead of 1 diagonally we are finding 2 and all other numbers are 0. So this is how to find out a square and then 5a is subtracted and the result is 2a. This is proof. Now one more important point, that A transpose and B transpose, if you multiply, then first transpose then multiply. Like A is a matrix 1 2 and B is another matrix. If I multiply A into B, if I want to multiply A into B, then we can multiply A then B. But if I say AB transpose, what will be the result? We will first multiply AB, then we will transpose. So if I want to know A into B, what is the result when transpose it? So first we will find out A into B. What is A into B? A first, then the B. So first row, first column. 1 2 will be multiplied with 4 5. 4 plus 10. 1 2 is multiplied with 3 1. 3 plus 2. 1 2 is multiplied with 0 1. 0 plus 2. This is first row multiplied with first column, then first row multiplied with second column, first row multiplied with third column. Now if I come to the second row, 3 0 multiplied with 4 5. That means 12 plus 0. Then 9 plus 0. Then 0 plus 0. Now the third row is multiplied with this one. Minus 4 plus 15. Then minus 1 plus 3 and then 0 plus 3. So what you are finding, that A is of 2 rows, 3 rows, 2 columns, 3 rows, 2 columns, 3 rows, 2 columns, and B is 2 rows, 3 columns. But when we have multiplied, the result is 3 rows, 3 columns. Very noticeable point. 2 rows, 3 rows, 2 columns. 3 rows, 2 columns. And it is 2 rows, 3 columns. Yes, we are multiplying because these two are same. This is number of columns, his number of rows are same. That is why we are being able to multiply it. And when we are getting the result, we are getting 3 3, means 3 rows, 3 columns. If you watch, you will find the result. So idea is A is 3 rows, 2 columns, B is 2 rows, 3 columns. So when we are multiplying, these two are same, means the column of this row of these are same. First matrix, number of columns, and second matrix, number of rows must be same. Then we get the multiplication 3 rows, 3 columns. So ultimately your answer is, ultimate answer of this question is, final answer is 14, 5, 2, 12, 9, 0, 11, 2, 3. But this is not the final answer, because we are discussing what is the result for A into B transpose. So if I transpose it, then the result will be not this one, 14, 5, 2, 12, 9, 0, 11, 2, 3. This is the final result. So this is the idea of matrix multiplication. One last concept I want to discuss, that sometime we get a very interesting result in matrix, and that result is, if I multiply A into A transpose of A is multiplied with A, the same as A transpose into A, and finally we get I. If I get a matrix of this kind, A matrix, A is a matrix of this kind, A into A transpose is A transpose into A, and both the result is I, then we say A is an orthogonal matrix. It's a very important concept, orthogonal. Orthogonal is very advanced knowledge of mathematics. Sometimes we don't need in normal thoughts, but orthogonal matrix is such a matrix whose transpose and the matrix, if you multiply, will be same if you transpose and multiply the other way, and the result will be I. Like A is equal to 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. I want to see whether it is orthogonal. Let us check whether it is orthogonal or not. Let us check whether it is orthogonal or not. So how to check? A transpose. That means we are changing the order, not order, the side. Row we are changing to column. Row we are changing to column. So we have taken rows into columns. That means this first row I have converted to column, the second row converted to second column. Now what you need to know whether A into A transpose, what is that? A into A transpose. 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. Multiplied with 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. Now we are multiplying. How to multiply? Root 2 into root 2 is 2. Root 2 into root 2 is 2. So first row, first column. 1 by root 2, 1 by root 2, that is half. Then plus, because first row, first column, half. First row, first column. Then first row, second column, half minus half. Then second row, first column, half minus half, and half plus half. So what you are finding? This is 1, 0, 0, 1. This is identity. When we are finding the identity, similarly we can show that A transpose into A. We must show that it will be same. So here the matrix A, which is 1 by root 2 minus 1 by root 2 and 1 by root 2 root 2. That means this matrix, this one, this matrix is an orthogonal matrix. So orthogonality will be traced if I take transpose multiplied with the given matrix to get an identity matrix. So this is a concept of algebraic idea of matrices. We have discussed today how to add, how to subtract, and how to multiply. That's more or less the concept of addition, subtraction and multiplication. That's all for today, basic ideas of matrices.